Vambora, rapaziada, voltamos. A live acabou caindo, meu PC travou. Fazer várias anotações e acabou travando. Uma loucura. Tá ruim? O PC tá ruim, hein, mano. Acabou travando. Uma loucura. Tá ruim? O PC tá ruim, hein, mano.
If you're lost in coding, it's probably because you
Vambora,
shouldn't be
rapaziada.
coding yet. It's almost always the case. You write out the concepts first and convert to code. In fact, I will grade your paper. If you write a beautiful algorithm and not a line of code, you'll still probably pass. Doesn't happen often because if they write the algorithm well, the code comes. If you turn in beautiful code that runs great without any comments in it, I give it back. That's how important this is. After midterm, anyway. So most beginners, this is so amazing. If you are a beginner, and I still am, you get to this point where you think you don't understand how to write the code. I can't tell you how many times people say, I know what I'm doing, I just don't know which code to write. No. Almost every time somebody says, I just don't know how to write it, no, that's not the problem. The real problem is they don't understand the problem they're trying to solve. They're jumping straight to coding without understanding algorithms. And I get that, because coding's cool, right? You look like a hacker. I showed my son HackerTyper. You know that site, hackertyper.com? Oh, you need this. HackerTyper.com, all you have to do is bang on the keyboard furiously, and it looks like you're writing C code. And if you hit the right control sequence, it says, like, you're in NATO or whatever. Yeah, it's awesome. Because that's what all of the students think they're going to learn how to do anyway. Yeah, now you're all going there. I love it. The real problem is that beginners don't always understand the problem they're trying to solve. They try to figure out how to do it before they try to figure out what to do. And really experienced people like us, we do that too, don't we? Every day. Every day. All right, here's one of my favorite ideas. And then we'll actually dig in and do some. Sound good? Comments are code. What? All right, so we all know what comments are for. Comments are there to explain code to other programmers. You agree? Sure. Which explains why we never write them, doesn't it? Because if the comments are there, first of all, it's their own dang fault if they can't understand my code. Secondly, I don't want to explain what it does until I'm sure I know, and that may never happen. Little painful little giggles there. Yeah, because this is true, right? We're all here. And I got to get this thing delivered, man. It's deadline. I'll do my best to get the comments in at the last step, but I got to get it working before I can worry about that. Yeah? So comments are there to explain the code to other programmers, or better yet, yourself, because a week later you're like, crud, what did this do? No. I finally learned the truth. Comments are not there to explain the code to programmers. Code is there to explain the comments to the computer. That's profound. That's all I got. Good night, I'll see you. Code is there to explain comments to the computer, at least for beginners. But again, I still consider myself a beginner. You write your algorithm first. You got that algorithm first working, it's beautiful. And then, how do you know it's done? It's like a turkey, right? The little thing pops out? No. How do you know that an algorithm is done? You look at every line, and at this point, maybe you've even decided what language you're going to use. And you say, I can do that, I can do that, I can do that. Oh, I better look that one up. Break it up into smaller things. I can do it, I can do it, I can do it, I can do it. At that point, now we can start thinking about code. That sounds really mean, doesn't it? My students think so too, until they do well. And they all earn more than me, so now they don't think it's so bad. So this is an important idea. All right, so let's go into, I said there were only 7 or 8 main concepts. Let's do our favorite first 4. How's that? No? 2. So they can start thinking about code. That sounds really mean, doesn't it? My students think so too, until they do well. And they all earn more than me. So at this point, maybe you've even decided to consider myself a beginner. You write your algorithm first. You got that algorithm first working, it's beautiful. And then, how do you know it's done? It's like a turkey, right? The little thing pops out? No. How do you know that an algorithm is done? You look at every line, and at this point, maybe you've even decided what language you're going to use. And you say, I can do that, I can do that, I can do that. Oh, I better look that one up. Break it up into smaller things. I can do it, I can do it, I can do it, I can do it. At that point, now we can start thinking about code. That sounds really mean, doesn't it? My students think so too, until they do well, and they all earn more than me, so now they don't think it's so bad. So this is an important idea. All right, so let's go into, I said there were only 7 or 8 main concepts. Let's do our favorite first 4. How's that? No? Okay, it's been nice seeing you again. Here's the way I like to think about it, because really, algorithms, you can say that, and people are like, nah, I don't know. But let me show you exactly how we like to think about these. I actually have one chart that I'll make, and it was uglier than the slideshow, so if you want it, I'll give it to you. But I have one chart, and I say, you understand this? It's an HTML table. It's that ugly. You understand this? You've got programming. Oh, you want to do it in Java? 1 second. Change it all. Okay, great. I changed one column. So I just rebuild that table for every language we teach in. But here's the ideas. Now, the first idea is about variables, right? Variables are about data. So those of you who are really beginners, today's our moment. If you're not a beginner, you're like, oh, no, that's right. But someday you're going to teach it to someone, okay? And the real issue isn't just a variable. Okay, it's a place in memory to hold data. Great, we know that. But here's the interesting thing about this approach to learning, is that I say, first thing you need to know is there is such a concept as make a new variable. And when I'm writing an algorithm, this is one of the things I can pick. What am I going to do? I'm going to make a variable. So that's on your drop-down list of things you can do. Make sense? There's only about 8 or 9 of these, really. But when you say that, as soon as you say, I'm going to make a new variable, some questions should pop in your mind. Oh, dear. Hey, there's some HTML code. Why did that just die? All right. So some questions should pop in your mind, right? Doesn't matter what language you're in. No, same questions. Anytime we make a variable, I guarantee you're going to need to know, what's its name? What's its type? What sort of data does it hold? Those of us who've been programming for a while know that computers are a little fussy about that. We have integers that don't have decimal point stuff, and we have floating point numbers that have that, and then we have strings, which is the much cooler way to say text. And then we got other stuff too, and it depends on which language, how fussy you are about that sort of thing, right? If this was a Java group, they'd be like, yeah, strict data types, baby. We're Python, we're like, man, it's all the same. We'll decide later. But does it still matter what type something is, even if maybe our language isn't too fussy about it? We shall see. Initial value, what's its starting value? So would you agree whenever you make a variable in any language, you think of these things? There might be some others like scope, but I'm going to save that for functions. Scope doesn't mean much if you don't have functions yet. So whenever I make a variable, that's what I think. Do you agree? Okay, here's where you say yes, no, yes, please go home. Okay, good, thank you. So how do you write an algorithm? This is the part I'm proud of. Okay, that's not the part I'm proud of. When it works, it's the part. See, the scrolls. How do you write an algorithm? Here's the beautiful thing. You must write in English. No coding allowed. Unless, of course, English isn't your favorite language, and Swahili, whatever. Cool, awesome. Create whatever it is. I don't care. But your sentence has to answer those questions. It has to answer the question, what's its name, what's its starting value, and what's its type. That's your algorithm. Does that make sense? So when we're teaching a beginner to make a variable, the first thing they need to know is, I need to make a variable. And then the second thing they need to know is, what question should I always answer when I make a variable? Does that make sense? And then when we do that, honestly, that's all they need. But see, if I could get away with it, I wouldn't even teach a language yet. But they don't believe it's real coding unless they're typing somewhere. So fine, we'll do it. That's how we write this in Python. Name gets an int val type, you're on your own. But that's how we do it in Python, so I can live with that. Can you live with that? Yeah, sure, because we're Python programmers. So that's good. So that's one of our concepts. Here's another concept. I mean, it seems trivial, doesn't it? But it isn't. It isn't. Output, right? What's another thing I can do? Well, I can tell the user stuff. I'm going to start here with the command line console because life is easier there, isn't it? We're in charge. I mean, in the GUI, the user's in charge, and who put them in charge? Not me. But output is pretty easy. There's only one thing to worry about. What message do I want to send the user? And of course, output's usually text, isn't it? Yes, it's text. Okay. Yeah, output's text. So that's pretty easy. And we could write an algorithm for an output line too, couldn't we? Don't worry, there's a quiz coming. Output the text message. Okay, that's pretty easy. Yeah, good code? Yay for Python 3. Yeah. System.out.println. No, console.out.writeline. No, it's easy as print. Except I always, yeah, see out, thank you. Printf. What's a printf? I don't know.
Mano, eu já fiz esse curso aqui, mano. Se não me engano, esse curso eu cheguei a fazer. Só que eu não sabia nada, mano.
You know, I still mess up the parentheses for sometimes because I did 2.7 for a long time. Wrote a whole book in 2, so the parentheses sometimes throw me, but I can do this. Now, how much are we worried about the Python syntax? Have you seen how much we've stressed about that? Why not? Because you all know it. But why? Because that's the part we can look up. How do I do it in this language? That part Google will help us with, won't it? If you try to Google, what problem am I trying to solve, you're going to get some very scary results. But if you know...
Rapaziada, eu acho que vou ter que desligar a câmera, tá? O celular tá acabando a bateria. Eu vou ficar sem câmera. Deixar carregando. Provavelmente eu vou voltar com a câmera quando a gente for fazer os exercícios. Já volto. Voltei, rapaziada. Voltei. Então, vambora. Eu vou colocar aqui. A gente vai ver esse aqui e é isso. Bora.
what you're trying to do. You know I'm trying to output text. You can say, how do I output text in Python 3? And the chances are you'll get something pretty close to this, yes? So the coding part is the easy part. The algorithm part is the hard part. All right. So we're getting to the point where we have enough of these tools we can start to put together a real program. There's, input. Now, input, I like talking about input because this is the first one that really starts to talk about the real complexity of coding, isn't it? Because, see, all of the other things were atomic. They could kind of stand on their own. But input is really mean. Input has, like, dependencies, doesn't it? I mean, think about it. When I input something, here, tell me the answer. Tell me the answer, come on. 42, that's a good one, I like that. Yeah, I'm coveting that t-shirt. It's not fair for me to ask you the answer if I didn't ask a question, is it? It's never stopped me as a teacher, but if I am asking for an answer, I should really give you a question. So an input applies that there was some question asked of the user. It may be in that statement, as it is in Python. It may be another line. It doesn't matter much. But somehow we're going to ask the user a question. Well, okay, now throw me the ball. Come on, throw me the ball. Come on, you guys can help. Throw me the ball, please. What ball? Yeah, you have a ball. Throw it. You know what I should have done? I should have put up my mitt. I shouldn't ask for somebody to throw something if I'm not ready to catch it. Yeah? Input. You have to have a variable to answer, to hold the answer. You have to have a question that you ask them. So the crazy thing about input is it should never be the first line of your algorithm. You see what I'm saying? It doesn't make sense because there's like prerequisites. And so you need to, either in the input statement itself or in another statement, you need to ask a question, and you already need to have a variable in place that can catch the answer. Well, that makes a lot of sense, doesn't it? And what does that have to do with Python syntax? Nothing. That's a different problem and an easier one, isn't it? That's an easier problem. Okay, so how would we do an algorithm? Again, any one you want, any line of algorithm, as long as it answers those questions, makes me happy. Ask the user a message and store the answer in variable. Beautiful. We good with that? You want to see code? You've seen the code, but it's easy. Variable gets input message. Yeah. But you see the point I'm trying to make? When we understand the concepts, the code itself becomes actually, at some point, and this is why we don't always write comments, right? At some point, this is more clear than that. But not for a beginner. Not for a beginner. So a beginner has to do this part for a while before they can jump straight to the code. Does that make sense? Because we've forgotten that sometimes. And to the beginners that we're trying to help, this looks like arrogance. It's not. It's forgetfulness. But we can see there's not a cleaner way to say that. I really can't think of an easier way to say that in any of the languages I use. Thank you, Guido. But we forget that it's not obvious to beginners. Okay, that's enough. We can write a program, can't we? Sure we could. With just that. All right, I'm not going to actually make you write it because I want to get to some other stuff. But here's the program we would write. Now, for real life, I would stop right here. No more. We've learned plenty. You can't make me teach you another line of code.
Você diz, né? Programação não é sobre linguagens, não importa muito. Tem muita... ficar decorando, né? Programação é realmente sobre resolver problemas. Estrutura de dados e algoritmo. Escreva os conceitos primeiro e depois converta para código depois. Comentários explica o código para outros programadores? Não. Comentário explica... Não. Código explica os comentários para o computador. Use pseudocode.
Because we would stop, we'd get out paper and pencil, and we would write some algorithms together in groups, not by yourself. If you're really confused, find somebody who's feeling very comfortable and make them uncomfortable. And we write this out. And if you turn on a computer, I will slap it shut on your fingers. Because I don't want computers right now, I want brains. Those are much better computers anyway, right? And so we write this. No code! That's really hard for those of us who think in code, isn't it? Yes, I sometimes do dream in code. It's terrifying. Especially when my dreams involve memory leaks. It's a bad, bad thing. Honey, just turn on the Valgrind. She's like, what's a Valgrind? Never mind. Algorithm only. I'll go ahead and do it for us. There's my first try. You see what I did here? No code. Create an integer variable for x. Create an integer variable for y. Create an integer variable for sum. Did I answer those questions? Yeah, okay. Ask the user x and put the answer in x. Ask the user y and put the answer in y. Put x plus y in sum. Tell the user the answer is sum. This is awesome. Okay, some of you know there's a problem. And some of you are like, seriously, I could have just written this. Right, but you're not a beginner anymore. If you're a beginner, you need to write it this way first. Now, here's the beautiful thing about Python, right? We're half a step away from Python because Python is beautiful, except for a few words. Come on. Name equals main. Yeah. That's pretty stupid. I love Python, but that's its word. Come on. It's still there. It's still there. And the whole self thing. Oh, please. If you're going to require self as a parameter, then tell me the right number of parameters when there's an error in the function, because my beginners are freaking the heck out. It says it only has 2 parameters when there's 3 missing, but there's 4. Okay, so first we just write this as plain text. Paper and pencil is better than on code. Whiteboard is my favorite. Lipstick on a mirror, cool. Blood on the wall, don't do that. But we come up with a plan. Then we take the plan, and now we convert it to comments. Now you can put it in your text editor. Which one? I do not care. If you're spending a lot of time stressing about it, wrong one. I'm actually still a Vim guy. I'm that nerdy. I know. All right, I'm there, man. Oh, I love me some Vim. But I'm not going to impose that on... Okay, second class I do. But in the first class, no, I'm not going to make you do that. But I want your editor out of the way. I'm not a huge fan of syntax highlighting. That doesn't solve the real problems, does it? Or code completion and all that stuff. That doesn't solve the real problems. That solves the easy ones. The real problem is, how do you think well? And the cleaner your editor is, the easier we get there. This is a pretty good answer, isn't it? Is it code? Well, technically, we could put it in an editor and it wouldn't crash. It's a great algorithm. Okay, at least it's a good algorithm. Would you agree? No? Yeah. No, I'm sad. Okay. I like it. Now the next step. Okay, now we can put in code. And so every line, and this again is something that we love to teach our beginners, or I do, everybody else hates it. And that is, okay, now that you've got those comments, one line at a time, you look for that comment and you tell me how to write it in code. Go crazy with Google if you want, do it. Of course, I taught this in China and they said, what's Google? Okay, Baidu, good luck. I got stories about that, man. Teaching Java in China. Please teach advanced Java in English. You've got 1 month. I got there and realized they didn't know basic Java or English. And that was the translator. Yeah, it was crazy. So now each of these things I can say, dude, I can write that. I can make that. And in fact, this is the first time that it even matters what language we're in. You know, maybe I'll go to the Java users group. I'll just change this slide. The others are fine. Except, you know, I can't make the comment about public static void main string args, which is, huh? Oh yeah, it's coming. Yeah, I'll show it to you. Yeah, I've got, yeah, don't you worry. Anyway, so we can take each one of these things and we can convert it to code. Isn't that beautiful? Isn't that beautiful? Yes, that's beautiful. Well, yeah. And then, of course, we can test it. And again, I'm not too fussy. If you don't have a copy of Python on your own machine right now, that's not a big barrier. I love some of the online environments. Python Anywhere, love that one. In fact, I've got it running on there, so you don't have to install it on your own machine if you don't want to. No good reason not to. Come on, you're using Ubuntu, right? You've already got it. Here, I happen to have it running, I think, patternworm.py. Okay. So there's that same thing I just copied and pasted. Should we run it? Oh, I am all of Twitter. Here we go. Okay. Come on, give me some code. Yes. I don't know what that is, but I think it's funny. Okay, x, 3, y, 5. This is going swimmingly. 35. Oh, dear. Really should have tested this, shouldn't I? No, I knew what was going to happen. See, look at my next slide. Stop it. Stop it, stop it, stop it. Okay, this is where we all go wrong. This is where we all go wrong. First of all, the first thing we do, failure is a wonderful thing. If you don't like failure, you're in the wrong business. Because how often do we have miserable crashes? A day, a minute. I mean, it happens all the time, right? If you can't be big about that, then you're in the wrong job. I don't know what job is good for you, but this one isn't. Because it's going to crash a lot. But our failures are opportunities for us to grow. And we have to have a good attitude about that. And you know what? We should teach debugging the very first moment. Because there is no programming that isn't debugging, isn't it? I mean, how much of programming is debugging and how much of it is actual programming? It's pretty much all debugging, isn't it? Begin debugging now. Now here's where everybody gets in trouble. One thing we all like to do, especially those experienced people, is we jump right at what the answer is, right? We start solving this sucker. And often, because we have a lot of experience, we do it very well. It really pisses the students off when I do that. I don't even see it. We're walking in the hallway and I can tell them what line's wrong, and I'm usually right. That really pisses them off, except at least their code's working. Because I've given this assignment for a few times and I know exactly why it's acting stupid. But did you tell it what to do incorrectly? That's what most beginners think. I must have typed the wrong code, because they still think that programming is about writing codes. That's what they always assume. Or did you tell it to do the wrong thing? Okay, we can think about this example. Did we tell it how to do it wrong, or did we tell it to do the wrong thing? Yeah, one of those. We don't know. That's a beautiful answer. We don't know. I don't know is the best answer any programmer could give me. Because if you do know and it's not right, you don't know. This is one I hate. I just have one simple problem, professor. Then why are you in my office? If it was simple, you would have solved it. You've done something boneheaded. I know, and I'll help you. But don't pretend it's simple. So often, we think that we just did it wrong, but what happened is we did the wrong thing. Maybe with a good conscience. But beginners almost always assume it's an implementation problem when it's almost always an algorithm problem. Is that the case here? Almost. It's an understanding problem. And that's okay. That's okay. That's wonderful. That's going to happen every day. And you know what? I could have
Então ele diz aqui, né, mano, que a maior parte da programação é a gente ficar debugando, né? Então, eu tô sem câmera aqui. Mas eu vou ver, a gente vai terminar esse vídeo e fazer o exercício e eu vou acabar a live, tá? Tem que sair. Estudar pra facu. Mas aqui ele tá dizendo, né? Comece a debugar agora. Normalmente, o problema é... Usually, o problema não é que a gente escreveu errado, né? A gente mandou ele fazer a coisa errada. Normalmente é um problema de algoritmo. Aí aqui ele diz... comentários... Código explica o comentário para o computador. Então a gente pode começar a utilizar pseudocode nos comentários, tá? Esse quarto aqui vai ser só pseudocode. Vamos fazer só pseudocode aqui direto, tá? E aí a gente vai traduzir. Traduzir o pseudocode pro JS. Então a gente vai fazer aqui direto.
That's okay. That's wonderful. That's going to happen every day. And you know what? I could have prevented that. I could have taught you how to convert to an int first, right? But I don't want to. Because the beautiful thing is embracing those, isn't it? Embracing the fact that when we learn how to code, we fail all the time. And boy, do you wish you'd learned this slide 100 years ago? I still don't know how. But debuggers are good. I like debuggers. Although you can depend on them. Okay, this is my Mr. Miyagi-ism of the day. Best way to debug code, not have bugs. Although it's facetious, is it true? Yeah, the best way to debug your code is to write code defensively so bugs don't creep in. That's very hard to do. It takes a lot of experience. There's other things you can do, though. Bad implementation. If I just did it wrong, I could Google that. If Google's not getting you the right answer, you probably don't have bad implementation. You probably have bad algorithms or a bad understanding of the problem space. Those are much harder to find in Google, aren't they? Bad algorithms, you can't look those up. There's probably something you're not understanding. Does that make sense? Something's not acting like it's supposed to. And that's when a debugger, the idle debugger is good. Again, I'm still a PDB kind of guy. I'm just that old school. Because man, a command line, dude, I can do a lot. But there's something I'm not understanding. Go in super slow-mo, look at that thing, print stuff out. See if you can find out something that you're trying to do is not doing what you think it is. You know, are there some tools that I can look at to help me? Of course, a debugger is good. In this case, you know, we could start looking at, hey, isn't there a command to find out what type something is in Python? Yes, it's called type. But here's the thing, it makes me crazy because I do it every time. Well, you know, here's what you need to do. Right? We start solving problems we don't understand. How often have you done that? Today. We are constantly solving problems we don't understand. And how often do we make them better? How often do we make them worse? So don't start with a solution. Unless you're using Git, then just, okay, make it a new branch and then go ahead. But don't start with a solution because you're going to mess yourself up, aren't you? And I have people come to me all the time. They just swear, Python is broken because it's not working and it should. Okay, there's something you're not understanding, and there's nothing wrong with that. But there's something you're not understanding, and your assumptions are probably a big part of the reason you're not understanding things. You're assuming things that aren't true. Do some detective work, Sherlock. Let's figure out what's going on. Let's get in there and find out what's happening. There's lots of tools for that. You got to start by understanding the problem. A lot of times, I'll turn off the computer. I'll be like, turn off that computer. Here's a whiteboard marker. When they moved my office, they were going to take away my whiteboard and my bookshelves. And I said, you can have my computer. True story. And they were like, you're nuts. Okay, we'll give you the whiteboard because you scare us a little. So what did happen here? Okay, now you can say, it's easy to assume the plus sign is broken. Dang it, this thing doesn't even know how to add. That's a normal assumption though, isn't it? How stupid is this? Now, that's not really the problem. Those of us who are experienced, see, we're feeling superior because we already know how, because we've already felt like idiots long ago when we forgot it. Or we're just kind of a little, because we've all made this one, haven't we? The plus sign is not really the problem. What's really the problem? Yeah, try this. Python has that interactive mode. I love that, right? If I try to do Python plus meetup, what's it going to say? Python meetup. There we go. Wait a minute. Wait a cotton-picking minute. You can't add Python in meetup, can you? Okay, be careful here, because you know I'm about to slap you. Because somebody wants to say, well, operator overloading is a form of polymorphism. And it's actually concatenating rather than adding because it's automatically detecting that these are strings and not integers. Yeah, slap you with a wet fish for that. When you're around beginners. Right? When you're around beginners, this is the worst thing we can say because they're like, yeah, you just switched into servo-correlation or something. They felt stupid before, now they feel worse. So yes, is all that stuff true? Yes, and is it wonderful when you understand it? Yup. But do you have to understand that the first day? No, I think it's enough to say, hey, the plus sign is so smart that it does different things when it sees text and when it sees numbers. And apparently, it thinks that 5 and 3 is text. I wonder if that's the problem. Can I test that? Right? And then we Google again. Is there a way to find out what type of data something is? Is there? Yeah. Is it type or type of? I get JavaScript and Python confused every time. I always guess wrong the first one. It's type. Okay. So we can apparently add text. Yes, concatenation. I wonder if things 2 and 3 are text. We look up a tool. The type function tells us what we want to know. Okay, now we add a new tool.
Mano, a gente viu essa questão de concatenação, né? Então aqui, basicamente, ele diz que programação não é sobre linguagens, não importa muito, e também não é sobre ficar memorizando as coisas. Programação é realmente sobre resolver problemas, a gente já tinha visto isso. E é basicamente algoritmos e estruturas de dados. Tá? Então, lit code, essas coisas é muito importante. E primeiro, ele diz assim, escreva primeiro os conceitos e depois converta esses conceitos para código. E como que a gente consegue fazer isso? Utilizando o pseudocode, né? Convertendo para código, a gente pode utilizar o pseudocode nos comentários e é isso. Né? E aí a gente vai convertendo linha por linha. E depois, se der algum erro, a gente consegue começar a debugar. Depois a gente vai ter uma aula que é importante, também debug, né? É entendendo os erros. Então, super importante, né? E a gente vai começar entendendo realmente o problema. Né? Então é isso que a gente está fazendo. A gente está vendo o problema e a gente está conversando. E é isso que é realmente que vale, né?
You see what I'm saying? Now we add a new tool to our toolbox and we say, all right, cool. I need a new algorithm piece. Convert to integer. Go look it up. Figure out what you have to do. Looks like we have an old variable, an int variable, and convert old variable to integer, store an int variable. Oh, look, there's code for it. That's all fun, isn't it? Now we have a new tool, and that's how we continue growing, is as we encounter a problem, we develop a new algorithmic tool to get there. Does that make sense? So this is pretty kind of fun, isn't it? It is really, in a geeky way. All right, I know. Now we can try again with a new tool. Notice what I did. I killed my code. I can't believe it took me hours to write that. No, it didn't. It took you about 30 seconds to write it. It took you hours to understand it, and you understood it wrong. Really hard to get people to throw away code, isn't it? Like us. All right, okay, fine. Put it in a subdirectory, but start fresh. Git, again, man, I love Git. But start fresh, because if it was worth keeping, it would have worked. And you didn't lose the thought process, you just got yourself in a bad place. So I'm going to rewrite my algorithm now, and I'll tell you the truth. I wrote this wrong the first time. I put it in the wrong order. But before I wrote any code, I was like, dude, that's in the wrong order. That's not going to work. You see this? I'm thinking about programming before I write code. Because it's often easier to see the order of things. See, I converted too early. But now that I look at that, I'm like, that makes sense. I could do that on a whiteboard. I can be the computer. And now we'll put some code in. Will this work? Yeah, we can prove it. I can run it, but it works. There's branching. There's for loops. I want to talk a little bit about while loops, though, and then we'll be done. You good with that? Because I don't know how long we're supposed to go, but, you know, it could be the next election cycle before I'm done. It's an endless loop. That's the problem. Yeah. Let's just skip this one. Okay, so, you know, for loops, people sometimes get mad, Python people, when they see the way that I teach for loops, because I say that a for loop has lots of parts. It has a sentry, it has a start, it has a finish, it has a change. And you're like, that is such a C++ for loop. What is the matter with you? And yeah, and I teach for loops in Python. You can see my code. For I in range, start, finish, change. Oh, that is so un-Pythonic. Yes, it is. Yes, it is. Because sometimes I want to teach Python and sometimes I want to teach programming. And when I'm teaching beginners, I'll do this. If Python uses second or third language, we'll do it with iterators. But this traditional structure lines up better with other languages, but much more important, it's much better for learning to debug properly. Because when you have a loop, what are the three things you always think about in a loop? Well, four things, really. First is the sentry. What is this variable that controls the whole thing, right? And then what are three things about the sentry you need to know? Sing along, people, you know this. Start, finish, change. How's it start? How's it finish? How's it change? Which seems so simple, right? But how many loops have you had that have gone terribly wrong? What's the most likely basic code structure to go wrong? A loop. Especially if you see a Boolean operator in that son of a gun. Death to Boolean operators. Yes. Yep. Or the falseness. You gave me that one. That was too easy. We're going to come back to that thought real quick. Anyway, a while loop. So what are the four things you need to know about a while loop? What's the sentry? How's it start? How's it end? How's it change? But no, that's not true, Andy. The while loop has only one parameter. That's the problem with while loops. The while loop implies a lot that it doesn't require. And that's why while loops go wrong so often, don't they? Because if you're going to make a while loop, you will also have a holy obligation to think about what the sentry is, even though the while loop doesn't require you to. You have to initialize the sentry before you got there, which means you have to plan ahead, which means why are you writing code? You should be doing algorithms. And then somewhere inside the loop, we don't know where, you have to change the sentry, and you have to change it in a way that guarantees that at one point you'll trigger the condition. Oh yeah, we need a condition. But you never forget that one. You will sometimes make a condition that's impossible to satisfy, though, won't you? Not a marriage seminar or something, but no. So these are the same things that are required in a while loop, and that's why I teach them first in a for loop. Because how easy is it to mess that up? Oh, you don't do it. All right, here we go. Here's the example. Basic password loop. We've all done this one, right? It exits with a positive result if the user chooses the right password. But if they get it wrong, it launches missiles. So if you get it wrong 3 times, sorry about your luck, sending the missiles. Right? We could all do this. How are you going to code it? Okay, really, how are you going to code it? All right, we'll use a compound condition, right? With a Boolean. Now, I love Boolean variables, don't get me wrong. It's Boolean operators that bug me. Because here's why. Because what condition do we need on this thing? Let's see. Tries is greater than or equal to 3, and guess is not equal to correct. Yeah, that's it. Or is it? Because now guess is a negative, and De Morgan's law, if it says a Boolean variable, okay, take a picture, because it can go away. So correct is IndiePy, tries is 0, keep going is true, while keep going. You know what I love about Boolean variables? There's just not a lot that can go wrong. It's about the cleanest variable type you got, right? I love Boolean variables. I don't love Boolean operators as much unless I'm working on just Boolean variables with them. But while keep going, if this thing is true, and is it? It better be. While keep going is true, do whatever code I want. Yes, I deliberately did not do the format thing because I don't want to freak out beginners. It's really cool, but not today. Now take a look. If guess is equal to correct, then we'll say, that's great, here's the treasure. And then look at this beautiful thing. That's where the break statement.
Mano, assim, Python é bem mais fácil que JavaScript, mas o JavaScript também não é difícil.
Goes, doesn't it?
Bem,
Now, we should
bem
never write
fácil.
break, should we? I know, switch statements. Thank you for not including those, Guido. Yeah. Keep going, it's false. That means the next time I evaluate this loop, we're out. How clean is that? And what do I really mean by this line? I don't want to keep going. I like that. Do you like that? It's going to be much easier to follow. Also, if the tries is, I didn't really do elif. Elif is like a dwarf, but it's taller in the ears. If tries is greater than or equal to 3, then we're going to print, hey, too many wrong tries, launching the missiles. Once again, we're not directly exiting the loop, but we're telling it the next time you evaluate, I don't want to keep going anymore. You know what's funny is I don't know the last time I wrote a while loop that didn't just say, while keep going. Because once you get used to this, man, it's beautiful. It is just beautiful. And I write a lot of games. You know, game code gets messy, doesn't it? Let me tell you, no code gets messier than game code. Partially because we don't design for maintenance in gaming. You know it's going to be out of date in a year. So in gaming, you don't design it to be maintained. You design it to be fast. And so you write some junk. Okay, eventually we'll teach all these things at their time, but not today. You good with that? Yeah, no. Let's just stop with this. So why Python? Right? I mean, I've taken a lot of time to tell you tonight that the language doesn't matter, yet it's a Python group. And I do love Python. So if the language doesn't matter, why did we choose Python? Well, I'll show you. Okay, you recognize this, right? What language are we in? Old school C, man, this is the way God intended. Pointers everywhere, no strings. Those strings are for wusses. All right, there's some C. And there's kind of, hello world is too simple to really get the feel of a language, isn't it? So I say, really, we need to do hello user. That is, it asks the user's name, and then it does something with it. That's the smallest program I think we can really get the sense of a flavor of a language. Would you agree? And would it be possible for me to take that little chart we just did and show you how to do all those things in C? Absolutely. Absolutely, there's C. But don't worry. Hey, Bjorn, how you doing, buddy? See, all these people in the open source world, they have the best names, don't they? You know, Guido and Bjorn and stuff like that. Yeah. I figured that's the only reason I'm not at the top of the open source world is my name is too obvious. I was going to go with one of those sub-Saharan languages with clicking and stuff. My name is Harris. Either that or just skip the human languages altogether, go to Dolphin. I'm sorry. All right, so C++. Wow, at this level, C++ looks like a dream, doesn't it? No more printf. C++ must be easy. Yeah, if you've done some. Yeah. If and def, anyone? Yep. Okay, C++ is pretty nice at this level, but it gets hard fast. All right, here's my favorite, right? Public static void main string args. Have you ever tried to teach Java to a beginner? Have you ever been to a beginner Java class? I mean, every Java teacher in the world who has to teach beginners, and this was me. That's what they wanted in Nicaragua. Please teach this in Java. I'm like, oh, okay, great. Please wave a dead chicken over your shoulder, turn around 3 times. It's a ritual, throw salt, type this line. And they're like, we do not have a chicken. Never mind, I don't really mean that. It's just a ritual because I don't want to teach you what a static method is yet. That doesn't make sense if we haven't done objects, and we shouldn't be doing objects yet. You're just trying to make a variable. So this makes me crazy. Now, I love me some Java. I do love Java. And I love Java for more advanced programmers because it doesn't let you do some stupid things that we like to do anyway, right? Dual inheritance. Now, I look at my kids. I think multiple inheritance is a good idea there. So there's Java. Yeah. It makes sense, doesn't it? Could we, again, like all these languages, could I take that chart and make it work for Java? Sure, I've done it. So why Python? That's why. If you want to teach a beginner to program, which of these languages is easiest to translate from the algorithm to code that actually works? That's what I love about Python. Because since I don't care about the language, how about we pick one that gets out of the way and gives them success? I want them to succeed. I want them to feel proud. I want them to fail, because that's going to happen, but I want them to overcome that failure. And so a language that helps us do that, that makes me happy. You hear what I'm saying? That makes me happy. And I like successful students. And here's the other thing. They are going to want to make games. Fine, we can do that. Somebody's going to want to write a database. SQLite's built in. Good enough. They all want to do GUIs. Okay, fine, TK. Yeah, TK. But, hey, it's built in. What do you want to do? Sure, we can do it. Get it out of your system. You want to do web apps? I taught that tonight. I showed them, this is their first Python class, I showed them Bottle because there's no installation. Because I don't want to deal with installing Flask on the computers. How cool is this? Isn't this fun? So that's really where I am. I love to teach beginners because I love the process of learning. And I always learn far more than them. So thank you for your time. I'll be around to answer any questions. You guys have been awesome. It's a lot of fun.
Então é isso, rapaziada.
Sim, a pergunta de $1 milhão.
So what I want to talk about tonight.
Então aqui eles dizem, né? O segredo não é código. O segredo é algoritmos e estrutura de dados. Escreva primeiro os conceitos, depois converta eles para código. Se você está perdendo no código, provavelmente é porque você não devia estar rodando ainda. Primeiro tem que entender o problema que você está tentando resolver. Então é isso, rapaziada. Agora eu vou só dar uma pausinha aqui. E já volto. E aí a gente vai começar a fazer coisa lá. Começar a fazer os exercícios. E aí eu vou fazer um pseudocódigo aqui. Aqui do coisa. Primeiro, o que que eu tirei desse vídeo? Sites. Programação não é sobre linguagens, tá? Não importa muito a linguagem que tu escolher. E também não é sobre decorar, sintaxe, etc. Né? Programação é mais sobre resolver problemas. E basicamente, né, o que tu usa para resolver os problemas na programação é algoritmos e estrutura de dados. Então tu tem que ter uma base muito boa de algoritmos e de dados. Eu fiz um curso em vídeo de lógica e algoritmo, né? Então a gente aprendeu isso. No Portugal é tipo um pseudocódigo. Aqui eles dizem, né? Escreva conceitos primeiro, depois converta para código depois. Aí ele diz, né? Comentários. Explica código para outros programadores. Não. Código explica comentários para o computador. E aí a gente tem que usar o pseudocódigo nos comentários. É interessante ter essa prática. Ele diz, né? Comece a debugar agora. Né? Normalmente quando tem um erro, eu penso assim, pô, será que eu escrevi errado? Aí ele diz, né? Será que tu escreveu errado ou você mandou o computador fazer a coisa errada? Né? Normalmente é essa questão. Provavelmente tu mandou o computador fazer a coisa errada, então provavelmente é realmente um problema de algoritmo. E ele diz, né? Sempre comece por entender realmente o problema. E é isso que a gente está fazendo, tá? Então a gente está aplicando, a gente primeiro está entendendo o problema, depois a gente está planejando e utilizando o pseudocódigo para planejar, depois a gente está convertendo basicamente o pseudocódigo. Então agora vamos fazer esse último exercício, tá? E como eu estava falando, mano, provavelmente eu vou fazer, quando eu terminar o Foundations, eu vou fazer um curso de C. Aí tu me diz, por quê? Porque eu quero pegar a base boa de algoritmo e estrutura de dados ao máximo. E eu acho que o C é o que ajuda, tá ligado? Eu acho que é a linguagem que mais ajuda a pegar isso. Então, é isso. Eu vou pausar aqui e eu já volto. Rapaziada, então vambora, vamos resolver aqui. A gente vai começar primeiro entendendo o problema. A gente só tem que fazer agora essa função. Aí a gente vai terminar o problem solving. Mano, foi uma das melhores aulas aqui do curso, porque, mano, essa questão de colocar tudo no pseudocódigo, entender o problema primeiro, como pensar como um programador sensacional. E todos esses insights aqui, mano, é pra sempre. Pra vida. Né? E como que eu vou fazer? Vocês entenderam. Amanhã vai ser dia 40, então, pô, muita satisfação. Vamos lá. Exercício. Cara, eu vou completo. Complete, tá? Querendo ou não, terminamos o problem solving, né? Temos todos os assignments, entendemos aqui, né? Qual que é os três estágios? É understand the problem, plan e define and conquer. Qual que é a importância do understand the problem first? Porque senão tu não vai conseguir fazer o algoritmo. O que você pode fazer para ganhar um entendimento mais claro do problema? A gente pode planejar, né? E planejar, tipo, qual que é o output necessário, inputs com a etapa necessária. A gente pode planejar e fazer essas perguntas. Quais são algumas das coisas que você deveria fazer no planning stage of the problem? Tipo, pseudocode, muito bom fazer essas perguntas, né? Principalmente a pergunta do qual que é o output desejado. E dados os seus inputs, quais as etapas necessárias para retornar o seu output? Essa é a principal, né? O que é um algoritmo, né? Pseudocode é o algoritmo, basicamente. O pseudocode é uma representação do algoritmo, escrito por inglês ou linguagem. Quais as vantagens de quebrar um problema down? Quebrar o problema em problemas menores. Evita tu ficar, tipo, em loops, em nós. Então, tipo, faz com que tu resolva o problema e saiba planejar, né? Pensar de forma estratégica ao resolver um problema de programação. Interessante a gente dividir problemas menores, tá? Então, basicamente, mano, aqui no site aqui que eles dizem, assignment, like a programmer. Diz assim, dado o output, quais as etapas necessárias para retornar o output? Dado o input, quais as etapas necessárias para retornar o output desejado? É basicamente isso que a gente tem que lembrar. Então, aí a gente pode utilizar então, a gente aqui, qual, copiar aqui, né? Qual que é o output desejado, né? Output desejado, mano. Retornar o resultado. Retornar o resultado da operação que o usuário responder. Escolher. Dados os inputs. Quais as etapas necessárias para retornar o output desejado? Ah, quais inputs o seu programa vai ter? E basicamente os inputs, né? Calma aí que eu já volto. 2 minutos. Então voltei, rapaziada. Então agora a gente vai entender o problema. Na verdade era pra gente ter começado a entender o problema. Calma aí. Qual que é o nosso problema? Né? Eles dizem, né? Entender o problema é quando a gente consegue explicar pra outra pessoa. Basicamente eu vou explicar o problema pra vocês, né? A gente, ó, basicamente, faça uma função que recebe dois números em um operador. Vamos dizer, mais, menos, vezes, divisão, resto, exponenciação, por meio de input. E depois a gente vai retornar o resultado. Então, basicamente, né, a gente vai fazer uma calculadora que recebe dois números. Então a gente vai pedir um input de dois números e um input de um operador. E aí, a gente vai dar esses três parâmetros, né, três variáveis, como parâmetros para a função. E a gente vai utilizar essa função para retornar o resultado dessa conta. E depois a gente vai colocar o console log dessa função. Perfeito? Então o console log a gente vai fazer tipo, toda a conta. A gente vai mostrar as variáveis, as três variáveis fazendo a conta. E é isso. Aí tu me diz, como que tu vai conseguir fazer isso? Case switch. Case switch. Tá. Agora, ó, quais inputs o seu programa vai ter? Dois inputs pedindo número para o usuário e um input. Então primeiro a gente começa, vamos começar, a gente vai pedir primeiro o primeiro número, depois o operador e depois o segundo número. E a gente vai fazer tipo a conta assim, dessa forma. Então é melhor. Então vamos fazer o seguinte. Ah, vamos escrever em inglês. A gente utilizou essa forma aqui, eu vou utilizar para eu vou me basear em mim mesmo. Vamos lá. Primeiro a gente vai começar. Fecha. Fecha, sim. Então a gente vai fazer isso, setar a função. Aí dentro da função. Hum, eu ver aqui, rapaziada. Eu não sei se o case switch tem alguma coisa. Aí vai ser tipo isso, tá ligado? Basicamente isso.
So what I want to talk about tonight, what Calvin asked me to talk about, so if it's a bad idea, text, and when it's the integer, store an int variable, oh, look, there's code. And what do I really mean by this line? I don't want to keep going. I like that. Do you like that? It's going to be much Python. It took you. So this is pretty. So I'm going to rewrite my.
Aqui eu achei interessante essa forma de tipo, colocar numa
Right, okay,
variável.
fine. Put it in a subdirectory, but start.
Agora vamos ver, rapaziada. Vamos colocar. E vamos começar a fazer o código. Hoje ninguém colou na live. Bad news. É que tô sem webcam também. E foi 2 lives, né, mano? A primeira caiu, esse tá muito ruim. Mas vamos lá, a gente vai utilizar esse aqui como pseudocódigo. E aí, fazendo esse pseudocódigo, eu vou acabar a live. Tá? E aí amanhã é Understanding Errors. Perfeito? Vamos lá. A gente fez tudo o que a gente fez, ó. Fez tudo o que eles falaram, né? E agora a gente vai utilizar o pseudo-comments, pseudo-code in the comments. E tomara que dê tudo certo, né? A gente entendeu, escreveu os conceitos antes, né? Então vamos lá. Agora, o que a gente tem que fazer? Primeira coisa que a gente tem que fazer, né? Aqui, ó. Get first number. Vamos colocar tudo. Vai colocar tudo. Aí, tipo, o pseudocódigo vai ser tipo uma explicação e a gente já vai fazer, tipo, eu tava olhando pra câmera aqui, mas tá sem câmera. A gente vai fazer, tipo, já explicar. A gente já vai explicar o código, né? Então, basicamente, o código é explicar o algoritmo para o computador. A gente tá usando esse método. Eu só não lembro muito do case switch, né? Então, vamos lá. Get let first number. Uh, Vou colocar uma musiquinha. Rapaziada, eu tenho uma playlist só de rock, tá? Mas eu gosto muito de música, mas canal de programação, então vambora. A gente só tá, tipo, convertendo o que a gente fez de algoritmo na programação. Então, cara, isso aqui é um pensamento novo, nunca tive esse pensamento e interessantíssimo. Ó, aqui a gente esqueceu do breaks, né? Basicamente a gente tá tipo, já explicando basicamente o que a gente tá fazendo. Então o código fica bem bonito, um código limpo, e a gente só tá tipo transmitindo o algoritmo. Então tipo, porra, é perfeito, tá? Perfeito ter essa lógica por trás. Interessantíssimo. E olha o que né, curso assim pode te ensinar. Sensacional. E rapaziada, amanhã vai ser Understanding Errors, então a gente vai tentar entender os erros. Ó, a gente já tá tendo erros. Então é pra debugar, tá ligado? Que deu erro, mano. Olha só. Vamos de novo. Tá vendo? Isso aqui foi erro de algoritmo. Eu escrevi errado, na verdade, né? Eu troquei os dois. E aí, aqui ó, o operator tava indo pro segundo, então não tava calculando. Então vou ver. 2 meses. De novo, ó. Erro de type. Tá vendo? Ó? Dá 22. Aí se a gente vir aqui, type of first thing. A gente vem aqui, parse. Vem aqui, ó. Viu? Então essa aqui é a arte de debugar, a gente errou. Vamos ver se vai funcionar. Perfect. Vamos ver. Então, número par. A gente vem aqui, fractal. Agora se a gente botar 2, 3. Vai dar nano. Aí é porque eu fiz merda. Mas se a gente fizer, tipo... aqui é foda. Bom, mas eu acho que é isso. Deu bom. Então... é isso, rapaziada. Hoje a gente fez o código, a gente viu colocar e a gente fez... Cara, hoje foi um aprendizado ferrado, tá? Hoje a gente aprendeu essa questão aqui de colocar o pseudocódigo e ir fazendo o código por baixo. E deixa o código bem mais bonito, mais limpo e ainda, tipo, melhora muito a tua lógica. Porque tu vai ter que fazer o algoritmo 2 vezes, mais ou menos, né? Aqui tu vai aprender a copiar. Sensacional. Ainda mais aqui que ele falou, né, que é a questão de... o código explica o comentário para o computador. O código explica o comentário para o computador. E isso é maravilhoso. É maravilhoso, tipo, mudou todo o meu aspecto de programação. Rapaziada, e... pô, Vale muito a pena. Tá, então é isso. Terminamos aqui Problem Solving. Recomendo muito esse curso. É isso, mano. Terminamos aqui. É isso. Amanhã eu vejo vocês. E valeu. Hoje foi mais ou menos 3 horas e meia de live.